I want to welcome everyone to today's webcast. We have Anji Cibarino from PTC presenting today. However, before we begin, I'm going to have some poll questions to be answered, and then we'll start after that. Okay, we have one more. That's it for our poll questions, and please hold your questions until the end of the webinar, and Angie will be happy to answer those for you. Angie, it's all yours.
Thank you, Rosalinda. Good afternoon, everyone. I am Anji Cibarino from PTC, and I am going to be delivering today's presentation on Mathcad Prime. So before we go into the actual application, I'm going to go ahead and go through some slides to give you an overview of what Mathcad Prime is all about. And so just very quickly, Mathcad Prime, I want to establish a little bit about the history and why we created Mathcad Prime. And some of you may already know about this, so just bear with me as I go through it. But basically, there were a lot of things that we wanted to introduce into the Mathcad application. And the historical traditional version of Mathcad became more difficult for us to build and on top of and incorporate new features. Because the software architecture was such that it had been developed a long time ago. The architecture was dated, and in order to add new and compelling capabilities to Mathcad, we needed to re-architect the entire product. And with that in mind, we had a couple of key goals. And one of those goals was that we wanted to redesign the user interface so that it would be much easier to use for our customers. You know, the previous user interface in traditional Mathcad is not difficult, but you need to know how to use it. And with the new application, with Mathcad Prime, we've redesigned the user interface. We've refocused our energy on making it more task-oriented and more user-friendly and easier to learn, so that anyone could conceivably open up Mathcad Prime and within 15 minutes be able to be productive and solve a basic type of a problem. So we don't want anybody to struggle once they start to use Mathcad, and so we hopefully have addressed that with Prime. And also we found that a lot of customers were spending time struggling with formatting their documents in traditional Mathcad, struggling with things like headers, footers, modifying equations, the equation editor, things like that, margins. And so we wanted to address all of that and make Mathcad Prime a much more document-centric application where those documentation capabilities are easy and they come naturally, and we don't have to struggle, and we don't have to spend a lot of time trying to fit headers in the way that we want them to go in and make them look right. And so things like that we really wanted to streamline and make the user experience much better in those documentation areas. So let's go ahead and just go to the next slide here. So Mathcad Prime is really the next generation of Mathcad. And as I said, we're going to have it's document-centric. So we have a very document-centric environment, which means that documentation should come naturally, and it should be much easier to document your work, capture your assumptions, your thoughts, your decisions as you go along, but at the same time create professional-looking engineering documents. Also, the user interface is redesigned so that it's easier to learn and easier to use. And then the third item here is that we've incorporated some additional mathematical functions and capabilities so that we have more capability for exploring advanced engineering. So, some examples of how Mathcad Prime helps. The user interface has been redesigned so that it's what we call a task-based user interface, and the idea is that everything is one click away. So instead of the traditional drop-down menus, now we have the Microsoft Ribbon user interface. So we've added the ribbon to the application so that we don't have to drill down into multiple levels or multiple layers anymore in order to be able to do things like format things, but we can just go up to the ribbon, select the appropriate functional area, and then click on the button. So everything is one click away. And so we call that the task-based user interface. We have a task, we know what we want to do, and within one click of the mouse, we can do it. Multiple document environment. So we have tabs across the top of the page now, very much like we have tabs in Excel at the bottom. We have tabs at the top, so we can just have multiple documents open at the same time, and then we can just click on the document and switch back and forth. There's no window drop down anymore as we had in the past. Okay, so it's much easier to see now which documents you have open, which ones are available, and to go back and forth between them very easily and very readily. There's an intuitive function toolbar. So all of the functions, the built-in math functions, as you know, Mathcad is a math engine at the core. So it has hundreds of built-in functions, and those functions can now be displayed simultaneously next to your actual document, so you can actually scroll up and down through the function library, expand topics. Okay, they're grouped into topics. You can expand the categories or expand the topics, find the function you need, hover over it, get immediate help, and so that panel can be displayed as you see here on the left-hand side, the right-hand side, or it doesn't have to be displayed at all, but you can display it if you want to. So it makes it easier to access the list of built-in functions as you're doing your work, versus in the past, you'd actually have to go to the View menu at the top, scroll down to Functions, or go to the Insert menu, insert a function. You'd have to drill down a couple levels. You get pop-ups everywhere. So it has really been cleaned up. We now have something called Spec Tables. So Spec Tables are different from matrices or arrays in Mathcad, and I'll actually show you what a Spec Table in Mathcad Prime is. It's very similar to the idea of columns of numbers in an Excel file. Okay, so if you have two columns of data in Excel, typically you might have a column header at the top of those columns to explain what those columns of data represent. And now in Mathcad, we have something that's very similar to that, and these are called Spec Tables. So you can create a table of data or a table of numbers, put headers on top of your columns, but those headers are intelligent headers in Mathcad Prime. Okay, and that means that whatever the label is at the top of the column automatically translates into the name of a variable that stores that column of data with its units. Okay, so those are new in Prime, and we'll take a look at those. They're very useful. 2D and 3D plots have been redesigned so that when you're formatting 2D and 3D plots, you can do so with one click of a mouse. Okay, you just go up to the ribbon, select the 2D plot category, and then you have all of the formatting options available right on the ribbon. So again, there's no double clicking required, there's no drilling down required, there's no clicking OK 2 or 3 or 4 times to get back up to the document level after you make a change to the format of a plot. We have a graphing paper interface on the background. So the traditional engineering paper, the graphing paper that we're all used to, is now the background for Prime documents. So there are 2 settings for the graphing paper background. There's a regular setting and then there's a finer setting. It can't be adjusted. Okay, there's 2 settings, and it really provides a nice looking professional engineering document, but it also gives you the ability to align things. And then the graphing paper can be turned off. If you prefer more of a whiteboard background, you can turn it off. So the equation editor has been redesigned. Okay, so it's more intuitive. We have collapsible areas, so we can hide and protect sensitive data, sensitive information, proprietary information. We have a symbolics engine, which in Prime 1.0, for those of you who have experimented with Mathcad Prime 1.0, we did not have symbolics. So in Prime 2.0, now we have full support for symbolic processing. And we also have 64-bit support and multi-threaded calculation support. Okay, so Prime 2.0 is a 64-bit application, and it's also a multi-threaded application. So we can run multiple calculation processes in parallel. We could never do that before. And the header and footer capability has been dramatically improved. Okay, so no more struggling with headers and footers. And you know, a lot of times people would take their Mathcad documents and export them to Word just so that they could get the headers and footers and page margins to do what they wanted. And now we don't need to go to Word anymore because we've integrated much better headers and footers into Mathcad Prime 2.0. And we have a WYSIWYG environment in Mathcad Prime, which means what you see is what you get. And there's a page view and a draft view, and I'll show you what those mean as well. So Prime 1.0. Prime 1.0 was released about a year ago, and these are some of the things that we supported. The task-based user interface, the what you see is what you get environment, comprehensive support for units, of course, the function library, 2D plots, spec tables, and a built-in worksheet converter. So that's Prime 1.0, okay? And here are a couple more things for Prime 1.0. Now in Prime 2.0, we have additional capabilities. Okay, so Prime 2.0, we have collapsible areas. Okay, so we can put areas into our documents to expand and collapse content inside of them. We have an Excel component. Okay, so that is something that we had in traditional Mathcad, but it actually didn't make it into Prime 1.0, but it is in Prime 2.0, and it's the Excel component, and it allows you to interact directly with Excel, to exchange data with Excel bidirectionally, okay, and it will actually embed an instance of the Excel file inside of your Mathcad document. Okay, so you can get outputs from the Excel file, assign them to variables in Mathcad, and then use those variables in Mathcad in your calculations or to graph 2 columns of numbers against one another, things like that. Okay, a lot of times people prefer to do certain things in Excel, things like pivot tables and sorting and filtering. So with the Excel component, we can send data into Excel, use the Excel component to sort and filter the data, or perhaps do a pivot and then get some output back into Mathcad. So we have full support for the Excel component in Prime 2.0. We have 3D plots, surface plots, contour plots, so 3D plots are included, and we have full support for symbolics. Okay, so we can solve, the Mathcad math engine has a numeric processor and a symbolics processor. In Prime 1.0, we did not support the symbolics processor. Now with Prime 2.0, we do support the symbolics processor, full support for symbolics. So we can solve things and evaluate things symbolically instead of numerically if we want to. And we've made dramatic performance improvements in Prime 2.0. And along those lines, as I mentioned before, we have multi-threaded support. We support 64-bit operating systems, and we take advantage of the extra processing power provided by 64-bit machines. We have new solvers. So for solving simultaneous systems of equations, whether they're linear systems or nonlinear systems, we have new solvers. And the new solvers are the Nitro solvers, and they are new algorithms, and they're more robust and they're faster, especially for things like optimization functions, or if we're trying to minimize the behavior of a system or maximize the behavior of a function. The Nitro solvers are actually much more efficient and more accurate as well. And then there's a couple of other things here. We've made some improvements to the sizing of the file when you save large documents, especially things that contain images. The files were getting quite large, and so we've tried to address that. And we've also improved the process of converting legacy information from traditional Mathcad documents into the new Prime document format. Okay, so I'm going to go ahead and bring up Mathcad Prime. So bear with me one moment here. And what I'm going to do is start out by just introducing the user interface. Okay, so we're going to take a look at just a blank document, and I'm going to go through a couple of things regarding the user interface. Okay, so momentarily you should all see your screen update, and you'll just see a blank document. And so I'm just going to take a few minutes to go over a few things regarding the user interface. Okay, so this is Mathcad Prime 2.0. Okay, that's what we're looking at here. And you'll notice that this looks very different from historical traditional Mathcad, from Mathcad 15, Mathcad 14, Mathcad 12, 11, and so on. So the user interface has been redesigned, and it's task-based, which means that everything is pretty much one click away. We have a task, we know what we want to do, and within one click of the mouse, or maybe two, we can do that. Okay, so this is the ribbon. Okay, and so this utilizes the Microsoft ribbon architecture, and we have different categories on the ribbon. So you'll see here the math category is selected. So on the math tab, we have a lot of different math functions and things that we might want to do that really fall into the math space. So for example, if we want to put a solve block in, we would click on the solve block button. If we want to put a text block or a text box in, we would click on one of these. We don't have drop downs anymore, so there's no view toolbars or insert function. There's no more drop downs. Okay, none of these are drop downs, these are tabs. And then within a tab, then you can see a collection of available things. Okay, so now, like for example here, for the operators, if I click on this, we will see a window pop up, okay, with different operators, and these are organized categorically. All of these operators used to be grouped into math toolbars. And you'd go to your view menu and go to view toolbars, and then you'd see a whole collection of toolbars. Now, all of these operators are grouped right here underneath the operators button on the ribbon. Okay, so if I want to take the derivative of a function, I'm just going to come here and click on ddx. Okay, and it's going to put it right into the worksheet, and then I can write the name of the function that I want to take the derivative of. Okay, so going back to the math tab here, these are the operators. Here are the Greek characters. So we have full access to all of the Greek characters there. Here are the programming constructs, okay, to write Mathcad inline programs, which are analogous to macros in Excel. Built-in constants, the symbolics button. So these are some of the things that are on the math ribbon. Okay, and we all know that Mathcad is a units intelligent application. So just very quickly, if I type in a units expression, like 60 yards plus 40 millimeters plus 5 inches plus 33 meters, and we hit the equal sign, we get an answer with units. Okay, so just as a refresher, the math engine is units intelligent. So it understands how units relate to one another, it understands how units convert, it understands which units are dimensionally compatible and which ones are not. So all of those things are built into the math engine. So very quickly here, it shows you what unit system you're working in. Okay, so it tells me I'm in the SI unit system. Okay, and that's right on the ribbon. And that is why the result is in meters, because I'm working in the SI unit system, and meters is the default base unit for the dimension of length in SI. So by default, the result is in meters. Okay, and then you can also get a complete list of units here, and these are organized categorically, and then you can scroll down through this list. Okay, so the user interface is very, very nice. You can see units of capacitance here, catalytic activity, charge, conductance, current. I'll just scroll down. Units of energy, flow rate, CFM, GPM, MGD, million gallons per day. When you hover over these, it tells you what the unit represents. So when we hover MGD, it says million gallons per day, but we can see if we're typing it into the user interface, we're going to type in MGD. Okay? Units of force, force density, force per length, length, of course. And so I'm just scrolling down through this list, and you can see the complete list of units in the units library. Okay, units of potential, power, pressure, resistance, substance, temperature units, degrees Celsius, Fahrenheit, Kelvin, Rankine, and the delta T, change in Fahrenheit, change in Celsius. Those are built in as well. And then, of course, torque, velocity, viscosity, and volume. Okay, so those are the units, okay, and they're right on the ribbon now. So as another quick example, if we just define mass and set mass equal to 6 kilograms, and then we set acceleration and set that equal to 4 meters per second squared, and this is really an example for the benefit of those who aren't familiar with units in Mathcad. If we type mass times acceleration, we get a result as 24 newtons. So the math engine knows what the relationships are. It knows when you multiply kilograms times meters per second squared, you get newtons. Now, new in Mathcad Prime, you'll notice that all of these units, everywhere we have a unit, it's in blue font, and it's bold, and it's italicized. Okay, so if you look here, the variable mass is italicized, and it's probably Times New Roman, and it's black. And the number 6 is black, some font, probably Times New Roman. But kilograms is a different font. Okay, and again for acceleration, meters per second squared is blue, and it's bold, and it's italics. Okay, it's a different font. So in Mathcad Prime, on the ribbon, if we go over to the Formatting tab, okay, I'm going to go to the Formatting tab. On the Formatting tab, we have all of the basics of formatting. So if you want to type in some text, you know, this worksheet calculates flow rate. You know, if we want to type in some text, there's some text. We have all of the basics of formatting. So we can highlight that text, and we can go up here, and we can change the font, and we can change the style and the size and the colors, and we can, you know, all of those things. Okay, so these are just the basics of formatting. So all of that is here. So I'll just make a change there, and we can make it bigger. Okay, so again, notice we're just going up to the top here. Now, one thing that I want to mention is that all of the keyboard shortcuts that we expect and try to use that we couldn't use in Mathcad before now work in Mathcad Prime. So if we want to underline this is a minor thing, but if we want to underline it, we can highlight it, and then we can just use Control-U on our keyboard, and it'll underline it. So that's, again, going back to the usability. We can do that now in Mathcad Prime. We couldn't do it before. It's a minor thing, but it really makes it easier, you know, so you don't have to keep going up to the top and clicking on the U or the B to bold or underline. So those keyboard shortcuts that work in Microsoft Office applications like Word, Excel, PowerPoint, now also work in Mathcad Prime. Now, going back to the units, newtons, meters per second squared, kilograms. Up here on the formatting tab, okay, we talked about this, formatting text on the left-hand side. On the right-hand side, we have a little drop-down window, and you can see here variable is what's selected right now. So if I click on this drop-down, you'll see we can apply formatting to variables, units, constants, functions, system words, and keywords. So everything in this drop-down can have a different format, okay, a different format. And right now, you can see that variable is selected, and it looks like variables are italicized, okay, and they're black. And so that's why variables mass is italicized and it's black. Acceleration is italicized and it's black. Now let's go down to units. It's telling us units are blue, navy blue, and they're italicized and they're bold. So you can see the B is selected for bold, the I is selected for italicized. If we go down to the color drop, the color is navy blue. That's why our variables are a different font. Okay, so now if we go down to constants, if we have any constants in our worksheet, okay, let's make our constants, I think forest green is selected, but let's just make them this dark red color, okay, and we'll bold them. Now you can't manipulate the size, okay, you can't manipulate the size. The size is what it is, okay, and the font is inherited from whatever font is set here. So now constants are maroon. So if I type in pi equals, you'll see pi, and I'll zoom in a little bit, is by default this maroon dark red color, okay, because that's a built-in constant in Mathcad. That's one built-in constant of several, okay, so that's burgundy or maroon. So this is where you can apply, we call them label styles. You can apply label styles to these items here, okay, variables, constants, units, function, built-in functions, system words, and keywords. So that makes it easy to distinguish between variables and constants and units, okay, because sometimes people might have a variable called m, but m is also a built-in unit for 1 meter. Okay, so if you really want to clarify what's going on and minimize confusion, this is a very, very compelling way to do that. Okay, so now also on the formatting tab while we're here, we have the ability to format numerical results. You know, so here if we go to pi, by default we're displaying 3.142, but if I select that and I go up here and under result format select scientific notation for that result display, that's going to convert it to scientific notation, or at least it should here. Let's see here. Why isn't it converting? I'm not sure why it's not converting. I'll have to come back to that. But let's change the number of decimal points. I can change the number of decimal points to 8, and then we get 8 decimal points. Okay, so again, everything is one click away, and in the past you'd have to double click on this result, you'd have to go through a menu, and then you'd have to click OK a few times, and then come back out to the top level and see if that's what you want. And if it's not what you want, you'd have to double click again. So, you know, it wasn't as streamlined, but now you click on the number, you go up here, and you just click on whatever you want to adjust. Okay, so now that's the formatting tab. So we've covered the math tab, we've covered the formatting tab. I'm not going to go in through all of these tabs in this much detail, but I want to point out a couple of things. Functions, this is the functions tab. So this is where the function library can be viewed. So if you want to go to data analysis functions, here's the category, click on the drop down, here are all of the functions for data analysis. And if you hover over any one of these, it'll give you a brief description of what that function does, as well as the argument list. Okay, local min takes a 3D matrix and returns the minimum. And you can see what the arguments are that are required to call that function. And if you click on F1, we have context-sensitive help. So click on F1, and the help page for this particular function, local min, will pop up. Okay, so you don't have to go to the help menu, put in a search term, and go through that process. You can just click on F1 here, and automatically the help will come up for that function. Now, if you want to view all the functions, I showed this in the slides. You click on this button, and the panel will pop up, okay, to the left, and you can move it to the right if you want. You can put in a search term here in this box at the top, and then all of these categories can be expanded out. So if we go to, if anybody's doing like signal processing and you want to do an FFT or Fourier transform, you click on this Fourier transform category, and it'll expand out and give you the list of functions for Fourier transforms. Okay, and then this can be collapsed back up. So I'm going to close that, and matrices and tables. Okay, this is where you have all of your interaction with tables of data and arrays of data. Okay, so you can insert a matrix, insert a table. A table is a spec table, so we talked about that. So here you can add rows, delete rows, very much like you can in Excel. It's much easier to do that now in Mathcad Prime. And we're going to come back and we're going to look at spec tables. This is your plotting tab. So you can format plots very easily by just coming to the plotting tab and clicking on the category here and just clicking on what you want to do. So changing the symbols on your lines, adding traces, removing traces, adding markers, all of those sorts of things are here. Changing the color of the lines and the style, things like that. Okay, we already covered formatting. This is the calculation tab. And this is where you can turn automatic calculation on or off and control how your worksheet calculates. And then the document tab, this is where you get all of your document-centric features like headers, footers, page margins, putting in page breaks, adding space, removing space, separating regions if you have overlapping regions, portrait versus landscape. All of those document-centric capabilities are on this document tab. Here's the header and footer interface, and then we also have page view and draft view. Okay, so in page view, you're going to see the document that will print when you print it. Okay, and that's what this dotted gray line will distinguish between. Everything to the left is going to be page view, but draft view will show you the non-print margin as well. So if you want to make notes here, this is the non-print margin. Okay, and you can only see this when you're in a draft view. So when you're in draft, so let's go back to page view. Okay, so I think what I'd like to do is just mention a couple more things, and then I'm going to go through a couple examples here. So look at those examples. I'm just going to show a couple of things here. So if we define a function, f of x, okay, we're just going to define a function f of x, and we're going to set that equal to variable, it's a function of x. And then we know we can evaluate that function at a point. So if we want to evaluate that when x is equal to 5, then we get a number, okay, negative 0.675. All right, but what we're going to do now is we're going to create a 2D plot. And I want to do this quickly just to show you a little bit about how you work in Mathcad Prime and what we mean by the task-based user interface. So let's plot this. So to plot this function, f of x, what we're going to do is we're going to go up to the plotting tab here. Okay, so now we're on the plotting tab. Now we're going to click on Insert Plot. We're going to select XY Plot. And that puts in the framework for the plot for you. Okay, and so now what we do is here on the x-axis we put x, because that's the independent variable. On the y-axis we type f of x, because that's the y data. And then there's our plot. Okay, and so now these plots can be resized, so you can maintain the aspect ratio if you expand on the lower right corner. But if you want to change the aspect ratio, you can also expand vertically or horizontally. Okay, so and then these plots, they're objects, so they can be dragged and dropped around and moved around just like any content in Mathcad can be moved around. Okay, so there's the plot. Now, let's do a couple of things with this plot. Let's add another trace. So we're going to, on the Y data, we're going to go back up here and we're going to click on Add Trace. So again, one click. Okay, remember, one click. Now let's type f of x plus 1. Okay, we're gonna shift this data, oops, up by 1. Okay, so f of x plus 1. Okay, and then there's another trace there. Now let's add a third trace. So we're gonna click on Add Trace, and here we're gonna type f of x minus 1. Okay, and so that's gonna be our third data set. And you can see here it automatically appears at the bottom. So it's much easier to do these things in Mathcad Prime. Okay, one click of the mouse. Now, let's see here. Let's change some of these styles. So we're going to go to our f of x data, and then we're going to go back up here, and we're going to change the color. So I'm just going to change this color to purple. Okay, and there's the purple line now. Okay, so now let's do it for the f of x plus 1. That one is black by default. Let's change it to this blue color. Okay, and there's that one. And then we can leave the third one as red. Then we get the legend down here at the bottom. You can see that. And so now, if we want to add markers, if I wanted to add a marker to this nominal trace, f of x, we'd go up here and we would, well, we could change the thickness of the line just by selecting a new thickness. And now you can see here it's thicker. And then we can do that for the other ones as well. So it's incredibly easy to make these changes. If we want to add a symbol to the line, we'll just add a symbol to the line here. I guess I could put circles on it. Well, that wasn't a good one. I'll go back to, oh, maybe X's. I don't know. You'd have to experiment with this. I've made the lines thick, so now the symbols are just adding more density to the lines. But that's how we do these things, okay? It's very easy. Now, if we want to add some markers, okay, if we want to add markers to the plot, we're going to click on Add Vertical Marker or Add Horizontal Marker. Okay, so if we put a vertical marker there, it puts in a placeholder where you want to put a marker for a specific data point. So if we want to mark a data point at x equal to 5, I'm going to put a 5 into that box. And then automatically we get this vertical marker going here down where x is equal to 5. Okay, and in historical Mathcad, traditional Mathcad, we could put markers on plots, but we could only have 2 at a time vertically and horizontally. So that limit has been lifted, and now we can have more than 2. I believe we can have 8 markers horizontally and vertically at the same time on a 2D plot. So you can see that it's very easy to interface with a 2D plot. So we have the traces category here. We have the markers category, which we just talked about, the styles for your traces, the color, the thickness, the symbols, things like that. There's something called plot background. So if you want we have the engineering paper here, which is very faint, but it's there, and it's set to the regular size mesh. And when you have a plot, that engineering paper by default gets blocked out within your plot. Okay, so if you want to display it, you're going to set that setting here. Okay, so you could have the background of your plot be white, it could be the color of the paper, or it could be transparent. So that's a little bit about 2D plotting. Now the other thing I wanted to show was the spec tables, and then we're going to go through some example files. So I'm going to go to the new page here. So in Mathcad, we could always create arrays of data. Okay, so if we have a column vector, we'll just call it, oh, let's see here. If I have a column vector called force, I'm going to go to the matrices, okay, and I'm going to insert a matrix, and I'm just going to create a column vector. Okay, I'm not going to create a 2D array of four entries. Okay, so I'm just going to say maybe we have 3, 6, 9, and 10. Okay, and then I'm going to apply the unit of kips to every element in that force vector. And then let's create another one. Area. Okay, so let's insert a matrix. So we're going to create another 4x1, and here, I'm just going to type in some random numbers as well. Okay, and now I'm going to apply the units here. Okay, now this is nothing new. Okay, we could always do this. So now if I wanted to do a calculation with those two vectors, let's divide them by one another. Okay. Force divided by area, we're going to get a resulting column vector. Okay, so this is nothing new. We could always do this in Mathcad before. But you'll notice the units are a different font, which is nice. We already covered that. Okay, and then if we wanted to change this unit to a different unit, if we don't want that in pascals, we could change it to KSI. Okay, and so now it's in units of KSI. Okay, we could change this to inches squared if we want. And so if we change the definition here, this result is going to be updated because now these numbers are going to be in square inches instead of square feet. Okay, so there's that math operation. So this is using Mathcad matrices, okay? So let me just write that down. Mathcad matrices. Now we have something called Spec Tables. Okay, and Spec Tables will let you create a table of data with intelligent headers. Okay, so let's put in a spec table. So now here we're going to click on Insert Table, and I'm going to put in two columns. Okay, now I'm going to give these columns a header. So I'm going to call the first one Force, and then in this box down here we can put in the name of the unit. So this is going to be kips, and the second column is going to be area, and the units are going to be inches squared. Okay, now we can put in the data. So let's put in the data. And I'm just going to tab through and put in some data here. I'm just typing in random numbers. Okay, so there's the data. Okay, now this is what happens. Let me move this down a little bit here. Okay, so force is now the name of a variable. These column headers are intelligent. Force is the name of a variable that stores this column of data with units of kips. Area is the name of a variable that stores the second column of data with units of square inches. So these column headers are intelligent column headers. They mean something. They store data. Okay, but you have the look that you would have in a spreadsheet. A lot of people like to do this versus doing it this method up here. You know, creating a force variable and then creating it as a vector and then assigning the inches at the end. Okay, like we did here. A lot of times you might prefer more of a table representation of your data. So now if we type force equals to display the force variable, you'll see that it contains this column data in units of force. Now newtons is the default for SI. Remember, I'm in SI, but we could convert that to kips and then we'll see the replica of the way we entered in the data. Okay, now let's do the same thing for area. Area equals. Okay, and that's in meters squared because meters is the default. Let's change that to inches squared because that's the way that we defined it. Okay, and so now there it is. Okay, and so now we have a force variable and an area variable that come right out of the column headers for our spec table. Okay, so that's how spec tables work. And now we can divide those by each other. Okay, force divided by area, just as we did before. We don't like pascals, we want KSI. Or we could even write kips per square inch if we want to spell it out. And now here we can assign this to a variable, capital P, okay, or pressure. Okay, and now we can use that pressure going forward in the next calculation. All right, so let's see. We've gone over the user interface. We've gone over some of the new features. I'm going to go through some examples now just to show you what a completed document looks like in Mathcad Prime. The first one, and I'll spend about 5 minutes on these, and then we can open it up to Q&A. The first one I'm going to pull up here is a shaft bearing calculation file. So this file calculates this file calculates the speed, the critical speed of a shaft bearing. Okay, so you can see here's the mechanical part, and we've defined some variables here. The outer diameter of the shaft with units of centimeters, the inner diameter as 9 centimeters, that's lowercase d, the mass, the shaft length. Okay, so and the grid here is the fine grid. Okay, the graphing paper. It's set to the fine grid, so you can see it's much more granular. Okay, so now here are some of the equations that calculate things that we need. The second moment of inertia, the stiffness coefficient, and the critical speed of the shaft. And that's ultimately what we care about, the critical speed of the shaft. And that's represented here as n sub c in radians per second. Okay, so I'm going to page down. A couple things to point out. In the footer, we have page 1 of 6. We have the date. We have the path. Okay, to the file. I know that these all seem like trivial things, but I'm pointing them out because you couldn't do those sorts of things before in Mathcad. Let's keep going. And the header, of course, here. Okay, so now this next section varies the outer and inner diameters and calculates the critical speed for every combination. So this right here, I'm going to select it with my mouse, is the spec table. We just went over spec tables. This is a spec table that has 4 entries for outer diameter and 4 entries for inner diameter, and we're going to process every one of those combinations for outer and inner diameters to calculate the critical shaft speed, and then also check it against a requirement. Okay, and in this Mathcad inline program, we have 2 for loops that are basically looping over all of the outer diameters, all of the inner diameters, and performing this calculation, and then checking it to see if it satisfies a requirement, okay, for the minimum shaft speed. So here's a very straightforward if statement that says if our shaft speed is greater than the minimum, then we pass, otherwise we fail. Okay, so we're going to return the shaft speed for all of these combinations for outer and inner diameter. So we'll have 16 results and 16 pass-fail results. Okay, and so here's our table of outputs. These are all of the critical shaft speeds we calculated, units of RPMs. Here's the pass-fail table. We have 16 entries. And all we're doing here is putting some column headers and row labels on so that the data we know exactly what numbers the calculations are using for outer and inner diameter. That's all that's doing. And then down here we have a couple of plots. So let me go down and show the plots. Okay, so there's the plot of the critical shaft speed. Okay, and here's this horizontal line as a marker. Remember, we talked about markers when we plotted f of x as sine of x plus cosine of x. We put a vertical marker at the data point of 5. This is a horizontal marker. Okay, so that's all that is. And this is a contour plot that is plotting the behavior of this checking of this function. Okay, if the outer diameter is greater than the inner diameter, or the inner diameter is greater than 0, then perform this calculation, and then we're plotting the results there. Okay, and the last plot is just our pass-fail table. So I'll go back up to the top here, page up very quickly. Okay, so that's one example. Okay, I'm going to go to another example. This is a electronic RLC analysis, very straightforward, first-order RLC circuit analysis. And So again, the header at the top here, we have the PTC logo, and we have all of our variables defined here. We're defining things like capacitance, inductance, angular frequency, initial frequency. Okay, so we can put in a value for the resistor, 5 ohms. Now, the purpose of this spreadsheet here is to show what the same calculations look like in Excel. Okay, so you can see here, this is just a reference point. This is what this file would look like in Excel. Okay, and we all know it would be, there's no visibility into what's going on. So now let's get past that and look at how we do this in Mathcad. Here's the calculation for low frequency impedance, high frequency impedance, and total impedance. Okay, those are the values. And now we're going to vary the frequency using a Mathcad inline program and plot the results. Okay, so this is the plot in Mathcad. This is the plot in Excel. Okay, to the right of it. And to the left is the plot in Mathcad. And we have several markers, horizontal and vertical markers. We have 4 vertical markers, and we have 3 horizontal markers. Okay, and so this is what the plot looks like in Mathcad. So that's pretty much that one. And the last example is a beam loading analysis that calculates the deflection of a beam. And this one actually has a cover page on it, and you can see here it has a date stamp, a document status, a revision number, so a description. So this one, a little bit more work went into the presentation of it. This is something that you would potentially deliver to a customer or a partner or a manager. Okay, and so in this worksheet, we're looking at this in draft view. That's why we're seeing dotted lines where we have page breaks. If you follow my cursor, this is a page break, and a dotted line going down where we have the non-print margin. Okay, so this is draft view. It's not page view, it's draft view. The other 2 documents we looked at were page view. Okay, and that's just a setting. We can go to the document tab, and we can convert this to page view, but I want you to see it in this format too, so I'm going to leave it. Okay, and so the first thing we're doing here is we're reading data in from Excel. Okay, so Mathcad Prime has some new functions called Read Excel and Read CSV. And so you can read data in from Excel. You just give it the path to the Excel file, and you could even give it the specific range of data to read in, okay, and the worksheet. So there's a worksheet tab called Moduli. So we use the standard Excel notation, the sheet name followed by the bang, exclamation point, and then the starting and the ending data cells. So we're reading in the data. We're assigning it to a variable called eData. Okay, and we're looking at it a little bit here. And now we're going to define the dimensions of the beam and some loading requirements. So the length is set to 15 meters, the width is 500 newtons, the load is 500 newtons. The position is going to be at 11 meters in. Okay, that's where right here, 11 meters in. Let's scroll down. We're defining some boundary conditions. Okay, the moment and deflection at the left and right ends of the beam. And then here are the calculations. Okay, calculations for force balance, shear, moment, deflection. This is ultimately what we care about, the deflection at data point X. How far into the beam are we? What's the position on the beam where we're calculating the deflection? Okay, so there's the equation. And here's the calculated deflection at L over 2. So what's L? If I type L equals, L is 15 meters. So at 7.5 meters, the deflection is negative 13 millimeters. Okay, and let's go down to the plots. So here are some of the plots. Okay, and you can see in this example, we have a transparent background on the plots. So the area behind the plots is not whited out like it was in the example that we did when we created our plot for f of x. Here, we've set this so that we still see the engineering paper behind the plot. Okay, so there's the first plot. This is the shear versus position. The second plot, the blue, is moment versus position on the beam. And this last third plot is the deflection versus position. Okay, and then that's just a summary table. Okay, and so there's the plot of deflection. You can see X is position on the beam in meters. Y is the equation for deflection at position X on the beam, and the deflection is plotted in millimeters. Okay, and then we have two markers to mark specific data points. So, I hope that the last 50 minutes or so gave you a good feeling for what Mathcad Prime is all about, and I'll just recap really quickly here, and then we'll open it up to questions. The application is much more user-friendly, and it's much easier to use, and the user interface is task-based, and I think that's the key thing. Everything is one click away, so it's much faster to use, it's much easier to use, and it's more in line with the future of software applications. And along the same lines, we've added some additional math capabilities as well. And it's a document-centric application, making it much easier to document your work and create professional-looking documents without having to export to another application like PowerPoint or Word or things of that nature. So I hope this was useful, and I hope it was informative. And I'm going to hand it back over to Rosalinda to manage any questions that have come in, and I'll be glad to take your questions at this point. Thank you, everyone, for attending. And if you have any follow-up questions, then we can answer them here as well. But if you want to go into a deeper dive or further discussion, then please contact CDT. This was hosted by CDT PLM, and so they would be your contacts for moving further. Thank you very much, everyone. Rosalinda, back to you.
The first question I have is, when is the release date of Prime 2.0?
February 22nd.
And then I have another one. How effectively can existing Mathcad 14 worksheets be pulled forward into Prime 2.0?
Okay, yeah, that's a good one. There's a built-in converter in Prime 2.0, okay, that will convert your existing files into the Prime 2.0 data format. So the Prime data format is different from Mathcad 15, 14, and before. Okay, it's a totally different format. So you have to run your worksheets through the converter, and the converter is built in. So when you open Prime 2.0, what you're going to do is you're going to go to the Input-Output tab. Okay, and I'm going there now. So I just clicked on the Input-Output tab. And on this tab, right here, there's a button called XMCD MCD Converter. Okay, so that will take your old files and convert them. So when you click on that button, you're going to get this little utility. It's a little converter utility, and you're going to click on Add Worksheets. Okay, and then you browse for your legacy Mathcad worksheets, and you can select more than one at a time. Okay, you browse for them, and you load them into this converter. Okay, and like you can go to a directory, and you can select the entire directory and add it at one time. So you're going to have a long list here if you have many files. And then once you have your worksheets loaded into this converter, you hit the Convert button. Okay, this Convert button will be enabled. Right now it's grayed out because I don't have any worksheets loaded. But you hit the Convert button, and it'll start the process of converting the worksheets into Prime. And it's not going to overwrite your original worksheets or your original files. Those original files will remain untouched. It's going to create a new file in Mathcad Prime 2.0 format, and it's going to automatically save it in the same location as the original file. So if you go, so you'll get a new file in Prime 2.0 placed right next to your original file. Okay, with the same name, but it'll have a different extension because the file format for Prime 2.0 is different, so the extension is different.
Anji? We're
Yeah.
about to be cut off in about 1 minute. There are many more questions. I'll give those to you, Angie, and we can answer those, and I will respond to all the questions. And we will have the webinar available via replay.
Okay, so basically the webcast is going to terminate?
It's going to terminate. I tried to extend it, but it wouldn't allow me to.
Okay, so send me the questions and we'll get them answered.
And everyone will receive an email with the webinar replay link. And feel free to contact me with any additional questions. And thanks for attending.